Okay, here's another hypothesis testing example that we're going to do using a randomization distribution in StatKey. In a survey of 300 motorcyclists from the Northeast, 173 wear a helmet. In a survey of 300 motorcyclists from the Midwest, 201 wear a helmet. Do these data provide strong evidence that the proportion of all motorcyclists who wear a helmet in the Northeast is lower than the proportion of all motorcyclists who wear a helmet in the Midwest? Okay, so once again, we need to start by making our hypotheses. So, do these data provide strong evidence that? Here's my alternative hypothesis. The proportion of motorcyclists who wear a helmet in the Northeast is lower than the proportion of motorcyclists who wear a helmet in the Midwest. Okay, so we need to label our two proportions. I'm going to have P1 be the proportion of all motorcyclists in the Northeast wear helmets. And I'm going to have P2 be the proportion of all motorcyclists in the Midwest who wear helmets. So then my alternative hypothesis is that the proportion of all motorcyclists in the Northeast, P1, is lower than, less than, P2. And my null hypothesis, that's my alternative hypothesis. My alternative hypothesis is that, my null hypothesis is that those two proportions are equal. Okay, I'm going to test this at the alpha is 0.05, 5% significance level. And the last thing I need to do before I make a randomization distribution is figure out what sort of sample estimate I'm going to use here. Now, really what I'm focusing on is the difference between these proportions. My null hypothesis is that the difference in the proportions is equal to 0, while my alternative is that P1 minus P2 is less than 0. So I'm going to estimate this difference in proportions by using the difference in the sample proportions. P1 hat minus P2 hat is going to be my sample estimate. So here I have 173 out of 300 minus 201 over 300, which gives me a sample estimate of negative 0.093. Okay, so there's my sample estimate. Okay, now in order to find a p-value, we're going to need a randomization distribution, and we're going to get that in StatKey. Here we are in StatKey. We are trying to do a randomization hypothesis test, so we're going to be working over in this area. Since we're looking at a difference in two proportions, we're going to click on Test for Difference in Proportions. Now, in this test, the null hypothesis is always going to be that the proportions are equal, so we don't need to change that. What we do need to change is the original sample data. We need to make it match with ours. So we're going to edit the data. So the group 1 count is, we had 173 out of 300 that wore helmets in the Northeast. And then in the Midwest, we had a count of 201 out of our sample size of 300 motorcyclists who wore helmets, so we can enter that. Okay, so now we have original sample. We can see that it reflects our sample data. This is the same sample estimate, negative 0.093 that we got before, so we know that everything's entered correctly. Okay, so now let's go back and take a peek. we have a less than sign in our alternative hypothesis. So when after we generate our samples, we're going to be doing a left-tailed test. Okay. So coming back in here, I'm going to generate my randomization sample. Let's see, I'm going to do 5,000 samples. So I'm going to go 1,000, 2,000, 3,000, 4,000, 5,000 samples. As I said, my alternative hypothesis was that P1 is less than P2, so I'm doing a left-tailed test. And then I need to change the cutoff value because my observed sample statistic wasn't negative 0.080. It was negative 0.093. So click on here and enter minus 0.093. Click OK. And now this gives me my p-value. It tells me the proportion of all these randomization samples that had values as extreme as our difference here, or even more extreme, is 0.010. So that is my p-value. So now we have our p-value equals 0.010. To make a decision about what to do here, I compare this to my significance level. This is less than my significance level, which was 0.05. So I reject the null hypothesis, which means that I do have strong evidence. To support the alternative hypothesis, so strong evidence that the proportion of motorcyclists who wear helmets in the Northeast is lower than in the Midwest. And that's my conclusion.